2, proving lines are parallel. We're going to start off with angle 3 and angle 5. The first thing we want to do is let's define what kind of angles we have with angle 3 and angle 15. Excuse me. So here's angle 3 and here's angle 15. And it looks like these appear to be alternate exterior angles. So if these two angles are each the same, that means line A and line B have to be parallel. So what we are doing here is we're proving the converse from what we did on the previous lesson. When I look at angle 3 and angle 5, again, these angles are alternate interior angles. However, if these two angles are each congruent, that means that line C is going to be parallel to line D. So sometimes it helps to hide up the other part that you don't need. Since we don't need, again, we're looking at angle 3 and 5. I would hide everything else on bottom because we don't need it. We don't need this for when looking at angle 3 and 5. So we can see that line A will be our transversal, and then that means C and D, line C and D have to be parallel. Angle 14 equals angle 16. These angles are corresponding, and so that means angle line C is also parallel to line D. Let's go ahead and label what these angles were. So these were alternate interior angles. 3 and 5. These were alternate exterior angles. There we go. And then these were alternate interior angles. And then angle 14 and 16, these are corresponding angles. It just helps for us to know for future reference. Angle 3 and angle 7, these are vertical angles. And that's not going to tell us any information regarding if lines A and B are parallel or if lines C and D are each parallel. So let's just put not enough info given. Angles 1 and 2, these are a linear pair. And just because we have a linear pair does not mean that any of these lines will be parallel. So again, we're going to put not enough info. Next we have measure angle 11 plus measure angle 10. These are going to be same side interior angles. And when two lines are parallel, these will always add up to 180 degrees, supplementary. So since we're told that angle 11 and angle 10 are in fact supplementary, then I can say that line C is parallel to line D. Again, we would want to hide or just focus on this drawing only when dealing with angle 11 and angle 10. So we're saying it's this angle and this angle. I do not want to look up here, it will throw you off. So just look at what we have here. We have B will act as our transversal, and then line C and D are each parallel. We have 7 ways that we can prove that lines are parallel. First way is, or one way is to show that alternate interior angles are congruent. And let's get more specific up here because this is actually 7 ways to prove that lines are parallel when cut, and remember cut means intersected by a transversal. Okay, so if we have a line that intersects 2 other lines and the alternate interior angles are congruent, then 2 of those lines are parallel. We can also show that alternate exterior angles are congruent. We can show that corresponding angles are congruent. We can also show that same side interior angles are supplementary. Remember, that's 180 degrees. And we can show same side exterior angles are supplementary as well. Again, they add up to 180 degrees. So this is a review from what we've learned. Next, we have two new rules, and these are actually more common sense ways that we can tell that each two lines are in fact parallel, and I think you'll find that these two are much easier to decide versus trying to define what angle that we have. So one way that we can tell, and this is going to sound very simple, is to show two lines are parallel to the same line. So let's scroll down and see what this new rule looks like. Alright, we're told that if two lines are parallel to the same line, then they are parallel to each other. So this is easy for us to see. I mean, we have line A, we have line B. If line A and line B are each parallel, all right, and then we have line C. And let's say, so let's have this in writing. We're going to say that A is parallel to B. We're going to say B is in parallel to C, okay, which therefore I can say A is parallel to C. And that should make sense to us. Alright, we're going to scroll back up to the other rule, and second rule is going to read, show two lines are perpendicular to the same line. So we're going to show two lines are perpendicular to the same line. So in a plane, if two lines are perpendicular to the same line, then they are perpendicular to each other. So let's make another drawing. We're going to label that line L. We have line M. And then let's label this line N. Put a 90-degree box here, put a 90-degree box here. So with those drawings, we are saying that if line L is perpendicular to N, and line M is perpendicular to N, then I can say that line L is parallel to line M. Okay, we can also say that in a plane, if a line is perpendicular to one of two parallel planes, then it is also perpendicular to the same line. So let's label these lines again. We have line L, we have line M, we have line N up on top. Put 90-degree box here. And remember that we can stretch this box all the way around. We don't have to, but it's assumed that since we have one 90-degree angle here, that this angle is also going to be 90, this angle is also 90, this angle is also 90. We just don't have to show it all the way around. So what I can say